We need to sort these numbers by using bubble sort 8, 7, 5, 11, 15, and 2. Now in bubble sort we need to repeat the number of passes, and the total number of passes will depend on how many elements are present. So in this example we are having 6 elements, so we need to do 5 different passes. So in pass number 1, what we have to do, we have to compare adjacent values, and if the first place value is bigger than the second next place, they need to be swapped. So we can see first we compare between 8 and 7. So 8 is bigger when compared to 7, so they need to be swapped. Next we compare second and third element, which is 8 and 5. Here also 8 is bigger than 5, so we need to swap those elements. Next we compare 8 and 11. 8 is smaller than 11, no need to swap. 11 and 15. 11 is smaller to 15, so no swap. 15 and 2. So when we see 15 and 2, 15 is bigger when compared to 2, so they need to swap. So by the end of first pass, in bubble sort, the most highest number of given will go to the end of the array. So we can see that here 15 has reached to the end of the array. So that become part of the sorted order. So we don't have to further process the last element. So we can see that in pass number 1, totally we made 5 comparisons, which is related to total numbers minus the pass number. So here pass number is 1 and total numbers are 6. So 6 minus 1 is 5. So totally we made 5 comparison in pass number 1. Let's go to pass number 2. So in pass number 2 we compare 7 and 5. So 7 is bigger when compared to 5. So it will get swapped. Next 7 and 8. 7 is smaller when compared to 8. So no swap. 8 and 11. 8 is smaller to 11. 11 and 2. 11 is bigger when compared to 2. So they need to swap. So we have finished with pass 2. So we can see that the second highest number reaches to the second last place of the array. So here 11 has reached to the second last place. So 11 and 15 now become part of the sorted order. So we don't have to further process 11 and 15. In this case, pass 2, we have totally made 4 comparisons, which is equal to 6 minus 2. 6 is total numbers present in the array and 2 is the pass number. Let's go to pass number 3. So here again we compare adjacent values 5 and 7, no swap. 7 and 8, no swap. 8 and 2, 8 is bigger when compared to 2, so they need to swap. So 8 becomes part of the sorted order by the end of pass 3. So in pass 3 totally we made 3 comparisons, which is equal 6 minus 3. Let's go to pass number 4. 5 and 7, no swap. 7 and 2, 7 is bigger when compared to 2, so they need to swap. So now the 7 become part of the sorted order. Totally we made 2 comparison in pass number 4, which is 6 minus 4. Let's go to pass number 5. Here we compare between 5 and 2. So 5 is bigger when compared to 2. So we swap it. So both 2 and 5 become part of the sorted order. In pass number 5, we made only one comparison, which is equal 6 minus 5. So when we look at the bubble sort with total n equal to 6 numbers, we made total 5 number of passes, which is n minus 1. Total n minus 1 passes starting from pass number 1 to 5. And in each pass, the number of comparison which we made in the first pass it is 5, in the second pass it is 4. Similarly for the last fifth pass it is 1. So we can see as the pass number increasing, the number of comparison is decreasing. So if we consider k as a pass number, the total number of comparison which we have to make in one particular pass is n minus k, where n is the total numbers and k is the pass number. In bubble sort algorithm, we require total n minus 1 passes to sort an array of n elements. Pass number k requires n minus k number of comparisons. So we can see bubble sort, how the bubble sort algorithm works. Starting from the first index, compare the first and second elements. If the first element is greater than the second element, they are swapped. Compare the second and third element, swap them if they are not in order. Repeat the process until the last element. This process is known as pass, and after the first pass, the largest element of the array occupy the last position in the array. This process has to be repeated for total n-1 passes. Bubble sort algorithm requires n-1 passes to sort an array of n elements. Pass number k requires n-k number of comparisons. Now let us see the logic for implementation of bubble sort. So we are writing the logic inside a function which is named as bubble sort. It takes two parameters. The first parameter is an array and the second one is the total numbers which is present in the array. So a is an array of numbers and n is the total number of values which are present in a. So here we are using a variable k for indexing from 0 to n-2, which will be n-1 passes. Now in each passes, we need to compare adjacent values. So for getting adjacent values, number of comparisons which we have to do, we are using the index variable I. So I will takes always the value depends upon the value of k, number of pass. So it will range from 0 to n minus k minus 1. So since we are starting from 0, we are writing n minus k minus 1. Now adjacent values will be compared a of I if it is greater than a of I plus 1. That is means the first place value is greater than the second place value. They need to swap. So we have written the swap between a of I and a of I plus 1. Then you have to include the logic for swapping of two numbers, and then we have included the logic for displaying of an array of values by using a function. In the main method, we have created an array variable x with set of values, and we call display function for displaying the array. And then we perform the bubble sort by calling bubble sort function, and by using display function, we display the array once again after the bubble sort. Execute and see your program whether you're able to perform or not. If you're able to perform, comment below.